Hello and welcome to my screencast of 26.3 Predicting VO2 Max scores. So to begin with, what is VO2 Max? VO2 Max refers to the amount of oxygen that a person is able to utilise during exercise. It's measured in millimetres of oxygen that is consumed in 1 minute per kilogram of body weight. VO2 max scores give insights about your cardiorespiratory fitness. This could be how long you are able to sustain periods of exercise, the intensity of that exercise, and also how quick your mile run time is. A person's VO2 max will differ from person to person. This is due to a difference in age, gender, fitness level, and outside factors like altitude and temperature. But there are always ways of improving it. To improve your VO2 max score, you must first test it. If you're lucky enough to get tested through gas analysis, it will give you a result and a score. From here, you may want to improve it, and there are ways to do this. High-intensity interval training, also known as HIIT training, is the best way to train to get a better VO2 max score. This type of interval training works by forcing your body to work at incredibly intense levels, which trains the body to pump more blood than usual to the muscles. It also trains your lungs to inhale more oxygen per minute. This inhalation is oxygen which is transported via the blood and into the working muscles. In figure 1 you can see the oxygen consumption and the exercise intensity values reaching a peak point which is circled, and this is the VO2 max of this person. In terms of what VO2 max can do for your health, they show a few things about a person and can be a good indicator for whether they are healthy or a non-healthy person. For an ordinary person, having a healthy VO2 max can help in several ways. It can help reduce the risk of type 2 diabetes, improves cognitive function, improves your basal metabolic rate, reduces the risk of cancer, as well as improving your general mood. To be able to test your VO2 max score as an ordinary person without specialist equipment, such as the gas analysis test, you can use a variety of tests such as the multi-stage fitness test or the Queen's step-up test. These both require very little equipment and are easy to complete. Now for VO2 max scores for different events, sports and different athletes. Some athletes and sports require different levels of VO2 max to others. For example, a triathlete will need a high VO2 max. This is because they need much more oxygen being pumped around their body as possible, as they are endurance athletes. They will be working hard for long periods of time and so will require a high VO2 max score. This is because their muscles will be working... Having a higher VO2 max score means that they can inhale more oxygen per breath, and inhaling more oxygen per breath means that the oxygen can get into the blood and therefore oxygenate the muscles for longer. A triathlete may even have one of the highest VO2 max scores, as it's an event that requires your body to be ultra fit and have the best cardiorespiratory system. This can be said for the majority of endurance sports as well. Other sports that require athletes to have exceptionally high VO2 max scores are games such as football and rugby, which require you to be running around and up and down the pitch for 80 minutes plus. A midfielder in football must run around the pitch for 90% of the time on the field, and so having a high VO2 max score will enable them to run for longer because they'll be able to inhale more oxygen per breath, and so their muscles will be getting the oxygen that they need through the blood. This may also give them an advantage over opponents. Sports such as weightlifting, discus, shot put, etc. do not necessarily need to have a high VO2 max score. This is because they're able to carry out what they do, it does not require aerobic energy. It requires a short burst of anaerobic energy from their muscles, and not repeated contractions of the muscles, such as seen in footballers. In conclusion, it depends on what sport or event you take part in that reflects how high or how low your VO2 max score needs to be or is. Within VO2 max scores, there are absolute and relative values. Absolute VO2 max is the rate of litres that someone inhales per minute. This is litres per minute, and the amount of oxygen that is inhaled per minute can obviously change because of the size of the individual. One person may be able to inhale more oxygen because they have a larger set of lungs than somebody else. This is why we have relative VO2 max. Relative VO2 max is the relative millimetres of oxygen per kilogram of body mass per minute. The relative value is used to compare between endurance athletes. As well as absolute and relative values, there are direct and indirect measures of VO2 max. A direct measurement refers to a measurement of the exact thing you want to measure. Direct measurements do not take anything but the exact thing they want to measure into account. A direct measurement of the VO2 max test would be the gas analysis test. This test involves having a mask around the client's face which directly measures the amount of oxygen inhaled per minute using advanced technology and computers to yield a result. Direct measures usually yield a much more accurate result. This is because there are less variables to be considered and it solely measures the thing you wish to research, whilst indirect measures are when you measure something by measuring something else. This can be seen when measuring someone's VO2 max through the multi-stage fitness tests or Queen's College step-up test. This is because although these tests give you a fairly accurate VO2 max score, it is worked out through equations and most of the time through estimation. When a client takes part in one of these tests, their score from that test is put through an equation which estimates the client's VO2 max. This is different to the gas analysis test, which gives you a straight-up VO2 max score. The multi-stage fitness test and the Queen's College step-up test have to go through equations before they give you your VO2 max score. There's also maximal and submaximal tests. A maximal test is one that uses the client's full effort and causes them exhaustion from the rate of exertion that they expended on the test. A maximal test would be the multi-stage fitness test. This is because it involves the client having to exert their full effort to complete as many levels as they can. Strong et al. 2019 explains that submaximal exercise is any physical activity whose intensity increases at regular intervals up to, but never exceeding, 85% of your maximum heart rate. To work out your maximal heart rate is 200 minus your age. A submaximal test would be the Queen's College step-up test. This is because the client is not exerting their full amount of energy, but is still exercising. A reason a client might complete a submaximal test over a maximal test is because they might have an injury that restricts them from being at their best, or age-related issues that stop them from completing maximal tests that could damage their health. In terms of VO2 max and athletes, VO2 max is a good measurement of cardiorespiratory fitness and can be used in numerous ways to help athletes or help people's general health. VO2 max helps athletes by being able to identify those with talent. If a group of budding cyclists took part in a gas analysis test to work out their individual VO2 max scores, cycling coaches would see this and potentially pick those who have a better VO2 max score, as they already have an advantage over the rest of the group. As well as helping athletes in their own sport, a coach may see a very good VO2 max score and encourage the athlete to take up another endurance type sport, as they would have more of an advantage over the others. Another use of the VO2 max for athletes is that they are able to track their own progression. For example, if an athlete uses the gas analysis test to work out their VO2 max score at the beginning of the season, records their results, and then progressively works at trying to improve it through training, and then test again after a period of time, you'll see how or if you've improved. Knowing how you've improved or how you may not have improved is a really vital way of progressing as an athlete and can give you both intrinsic and extrinsic motivation to achieve more and get better. The VO2 max also allows athletes to monitor their exercise. Swain et al. 1994 explains that using statistical procedures examined the relationship between heart rate max and percentage of VO2 max. Their results led to the following. Percentage of heart rate max equals 0.64 times percentage of VO2 max plus 37. This showed that there was a direct relationship between exercise intensity and someone's VO2 max score. This can then be used to decide whether or not that athlete is working hard enough within exercise or not. Finally, the VO2 max test can reveal the intensity of an athlete. This is in terms of intensity in terms of speed. You can see in figure 2 below that the VO2 max scores are a direct representation of how fast someone is working. If as an athlete you took the VO2 max test and your score revealed you were working below the average speed, you could work on improving your intensity, so that next time you took the test you would improve. This is my literature review of the gold standard gas analysis test to ascertain whether it has validity, reliability, accuracy and precision. So to begin with, Nordgren et al. 2014 conducted a study, criterion validation of 2 submaximal aerobic fitness tests, the self-monitoring Fox walk test and the Astrand cycle test in people with arthritis. This study looked into how 2 submaximal tests, the self-monitoring Fox walk test and the Astrand cycle test, compared to the gas analysis maximal test in people with arthritis. Nordgren explained that the paired t-test revealed a significant difference between the tests, and the Fox walk test overestimated VO2 max by almost 30%. Knowledge that the Fox walk test overestimated the participants' VO2 max score helps to understand that this test cannot be used confidently for estimation of VO2 max on the basis of the correlation and agreement analysis. Pearson's correlation coefficient ranged between R value of 0.452 and R value of 0.81. The validity of this test is fairly high, as it does measure the VO2 max of participants, however inaccurate or precise they may be. The Fox walk test overestimated the VO2 max scores of the participants by 30%, and so is not an accurate test. Accuracy would suggest that the estimation of the participants' VO2 max scores would be correct. Here the scores were not correct in comparison to the maximal VO2 max test, further suggesting that the accuracy of the maximal VO2 max test is high or higher. This is backed up when Nordgren explained that 24 of the 27 participants achieved a respiratory exchange ratio greater than 1.1. This is the amount of carbon dioxide produced and oxygen produced during exercise, and shows how it accurately measures the inhalation of exercise per minute. 24 of the 27 participants that were involved in the test achieved this ratio, which is a percentage of 88.8%, an accurate and precise percentage for this test. For the Astrand test, Nordgren compared it to the maximal VO2 max test through the paired t-test, which have revealed a significant difference between the tests, and the Astrand test underestimated VO2 max by almost 10%. This again shows that the test was not accurate, as there was an underestimation of 10%. It would suggest, though, that this test is more accurate and valid than the Fox walk tests, but not competent as the maximal VO2 max test. Nordgren later explained in the study that the assumption of a linear relationship between heart rate and VO2 max makes the estimation of VO2 max from a submaximal test strongly dependent on the accuracy of age-predicted maximal heart rate. This suggests that the accuracy and reliability of this test is low. This test relies on the accuracy of age-predicted maximal heart rate, which can be worked out by using different methods. Some that agree with others and some that do not. Using Tanaka's, which is 208 minus 0.7 times their age, and Nez's, which is 211 minus 0.64 times their age formulas. The outcome was pretty close to the estimated VO2 max scores, whereas the Fox-Haskell formula, which is 220 minus your age, was found to underestimate the estimation of VO2 max scores. This suggests that reliability of this test is low because it relies on different formulas that will each yield different results, and so it cannot be repeated. Finally, to assess the validation of the gas analysis maximal VO2 max test, the rate of perceived exertion was looked at in all three tests, but specifically the maximal VO2 max test. The rate of perceived exertion for this test was measured across all of the 27 participants that took part. All but one of the participants recorded their rate of perceived exertion as 17 or more. Figure 3 below shows the Borg rating of perceived exertion, and on the number 17 it states that the exertion is very hard. The high rate of exertion across most of the participants shows that they exerted maximal effort, which increases the likelihood that they are inhaling the most amount of oxygen into their lungs per minute, which is exactly what VO2 max is. Confirming the validity of this test. The Fox walk test had an average of 15 for the rate of perceived exertion. This is labelled hard in figure 3. The average of the rate of perceived exertion was 15 with a low of 9, which suggests that some of the participants did not find the test very hard. This means that the likelihood of the participants inhaling the largest amount of oxygen per minute during this test is low, reducing its validity. To finish, although the validity of the gas analysis test is the best of any other test, the test's ecological validity is low. This is because in order for the test to be carried out, a mask must be worn, as well as a heart rate monitor and any other wires and tubes that measures the rate of oxygen going in and out of the lungs. This sort of equipment is not worn in any other sport, and so it could affect how athletes perform in the test. It could decrease the penultimate score of the test for the athlete, therefore not producing an accurate score. This is the method. Before carrying out any testing or retrieving any data from the participants, each participant carried out their own informed consent, filled in their medical questionnaire, filled out their own Part Q, and were made aware of all the necessary risks or hazards that may occur during testing. The purpose of this test was explained to the participants, highlighting the importance of understanding what VO2 max scores represent in terms of someone's health and how they might be used to track an athlete's progression. The right to withdraw is also vital for testing. It obviously allows the participant to withdraw at any time if they feel uncomfortable or for any reason, actually. As well as the participants' own PAR Qs, informed consent and medical questionnaires, the researcher needs to complete a risk assessment which underlines the risks associated with the test, as well as giving any control measures in place to stop the risks from happening. The researcher also needs to familiarise the participant with exactly what the test will include. This means explaining the procedure and what will happen with the results in terms of data protection and where the data will go from the test. This is controlled completely by what the participant wants to do with them. The researcher should highlight the possible effects that the participant might endure and what will happen in order to reduce or repair these possible effects. The two tests that we used to measure participants' VO2 max scores were the multi-stage fitness test and the Queen's College step-up test. The method of the multi-stage fitness test. To begin with, there was a pre-test procedures that have to be carried out for the multi-stage fitness test. After obtaining all of the necessary health screening documents and questions, next should be measuring the client's basic information, such as their height, weight, age and gender. To prepare for the multi-stage fitness test, cones should be laid out 10 metres apart and should have enough room at either end for a runoff for safety reasons. This is to avoid participants running into walls or surrounding equipment. The multi-stage fitness test also includes a speaker, which should be loud enough for the participants to hear. This speaker should play the soundtrack to the multi-stage fitness test, which includes its own metronome, which the participants should keep in time to. As well as equipment preparation, the participants themselves should also be prepared. This means that they should all go through a rigorous warm-up to ensure that no one injures themselves when completing the test. This also means that the participants should have shoes that are grippable to the surface. This ensures that they do not slip or trip over during testing. The protocol for the multi-stage fitness test is that participants start behind one of the lines facing the opposite line. When the soundtrack tells them to begin, they begin running to the other line. Once they reach the line, they can only run back to the original line once they've heard the bleep. To begin with, the pace is slow and is about getting the participants used to the technique of running in time with the bleeps. After some time, the soundtrack speeds up and gets harder for the participants. Our participants continue to run between the two markers, ensuring that they are on time with the bleeps. If the participants do not make it to the line before the bleeps, ensuring that they're within 2 meters, then they are warned and must catch up with the pace within 2 more bleeps. If they cannot catch up, they are eliminated and their score is taken. Scores are recorded by the level you are on and the number of shuttles you have run in that level. For example, if a participant made it to level 10 and was on their second shuttle before stopping, then their score would be 10-2. Now you have a participant's score. It is then entered into a specific VO2 Max calculator, AMADI 1992, where the participant's VO2 Max score is predicted. You should also record the participant's heart rate, which can be measured on the heart rate monitor that they should be wearing. Now for the method of the Queen's College step-up test. After the participants' health screening was completed and their basic information was obtained, there was some pre-test organisation and preparation to be done. Firstly, the test procedure was explained to all participants that were taking part. This ensures that the participants know what they are doing, as well as any techniques that should be shown along the way to perform a step-up with the correct cadence. Other preparation consisted of setting up the step, which must be 16.25 inches or 41.3 centimetres high. Similarly to the multi-stage fitness test, there is also a soundtrack to this test. Its sole purpose to be a metronome to keep the participants in time with one another. A speaker must be set up with a soundtrack played through it so that all participants can hear it. The soundtrack for males and females is different. For males it's 22 steps per minute, and for females it's 22 steps per minute, and for males it's 24 steps per minute. As well as equipment preparation, the participants need to be prepared. This is through a well-done warm-up to ensure that the blood begins to move around the body into the working muscles. The protocol for this test is fairly simple. Participants stand behind a step that is 16.25 inches or 41.3 centimetres high and step up onto the step in time with a metronome that should be played out of the speaker. The metronome follows an up, down cadence that the participants should follow. Our participants follow this 4-step cadence for 3 minutes. For females, it should be 22 steps per minute, and for males, this is 24 steps per minute. Once the 3 minutes is up, the participants should sit down and start to measure their heart rate. This should be done for 15 seconds. Whatever score they get here should be multiplied by 4 to get your beats per minute, and once our participants have their beats per minute, they should use the formula produced by McArdle et al. 1972. This formula will then calculate the participants' VO2 max score. The results for the multi-stage fitness test. Once all participants have completed the multi-stage fitness test, all the results are collected and put into the VO2 max calculator. This calculator converts their scores and produces their VO2 max score. Once these results were collected, they were used to assess how the participants performed in comparison to other athletes of their chosen sport. One participant of the multi-stage fitness test had a relative VO2 max score of 49.3. This was calculated using a participant's shuttle score of 10.8. It was established that the participant was 18 years of age. The score was then compared to normative score values in Figure 4 of other 18-year-old males. Figure 4 showed a rough average of other 18-year-old males completing the multi-stage fitness test. This participant would be in the good category. Johnston et al. 2010 completed a study into the physiologic profile of professional cricketers. Within this study, professional cricketers completed a multi-stage fitness test, which yielded an average score of 12.4 with a standard deviation of 0.9, which is an increase of 1.6 level and 6 shuttles over this 18-year-old cricketer. These professional cricketers had a predicted VO2 max score of 54.9 with a standard deviation of 3.7, an increase of 5.6 over the 18-year-old, suggesting that this participant is below where they should be for their sport compared to the elite standard. Although the participant had a score that achieved the good category for his age, it was below the average score for professionals playing cricket. This means that when playing cricket, the participant may not be able to use their working muscles for as long as others. This is because there is less oxygen in the blood that flows through the muscles, meaning their performance is reduced in quality. The participant will struggle to keep up for as long as other cricketers, as they will have a better VO2 max score. For example, if this particular cricketer was a batsman, this could mean a lack in effort if his team needed a single off the last ball of the game to win, but he could not get there in time because his muscles were deprived of oxygen to be able to complete the task. The strength of this participant score is that it falls in the good category for his age group. This suggests that this participant is as fit as other people his age. They can use this for motivation to reach the quality of professional cricketers in Johnston's study. To be able to reach the level of professional cricketers and improve their VO2 max, the participant will have to train via interval training, as this is the most effective way of improving a person's VO2 max score. A simple high-intensity interval workout that the participant can get involved in could be a 2-minute warm-up, depending on the pliability of muscles, consisting of a light jogging between 10 metres of space and static stretching, focusing specifically on lower limbs such as the hamstrings and quadriceps. After this warm-up, the participant then has a series of exercises to complete. These are all 2 minutes long. These exercises are burpees, press-ups, sit-ups and mountain climbers. These exercises should be 2 minutes long with a minute's rest in between, and the participant should try as hard as they can to do as many repetitions of these exercises before the 2 minutes is up. Once all the exercises have been completed, a 2-minute cool-down is a necessity. Similarly to the warm-up, this should include a light jog to bring the participant's BPM back down to resting, and static or dynamic stretches to reduce the chance of lactic acid build-up. A repetition of this training should be repeated 4 times a week. An improvement of their VO2 max should be seen if they stick to training. Results for the Queen's College Step-Up Test. Once all the participants finished their Queen's College Step-Up Test, their results were recorded. They were all converted into VO2 max scores using McArdle's 1972 formula. Looking at the same athlete, they had a BPM of 33, and using the formula, they recorded a VO2 max score of 55.9. Using figure 5 below, which is a normative value table for 16 to 90-year-olds who do not take part in sporting activities, you can see that the participant's BPM score of 132 would be in the above average category, suggesting that on average he is better than the average BPM score after completing the Queen's College Step-Up Test. Using the previous study, Johnson wrote, it highlights how the professional cricketers had a predicted VO2 max score of 54.9 with a standard deviation of 3.7 when completing the multi-stage fitness test. Previously, this participant had a score of 49.3. Although these are 2 completely different tests, we can see how they produce 2 completely different results for the same participant, and so can argue over the accuracy of these tests. This then begs the question whether this participant is at the same level as the professional cricketers, as one test puts him significantly below, whilst the other puts him above. If the participant wishes to improve their VO2 max score, then the interval training on the previous page can help. Finally, the discussion. The comparison of the data between the two tests was helpful. The Queen's College step-up test gave the participants, on average, a higher VO2 max score prediction than a multi-stage fitness test, suggesting that the accuracy of the two tests may be low, or that one is inaccurate whilst the other is not. A correlation and paired t-test was then used to ascertain a p-value. These tests gave a p-value of 0.752. The p-value here suggests that there is a weak correlation between the two sets of data found by using the two separate tests. The finding of the p-value and the suggestion that there is a weak correlation between the two tests tells us that neither test is accurate, or that one of the tests is more accurate than the other, which is the more likely scenario. Using a gold standard test such as the gas analysis test to find which test is closer to these results could be one way of finding out which one is more accurate, but can also be achieved through looking at the mean difference of the tests. This is at 10.17, which is a large difference for tests that are trying to measure the same thing from the same participants. Chatterjee et al. 2003 conducted a test into the comparison between the Queen's College step-up test and the gas analysis test to find out how feasible the Queen's College step-up test was for trying to ascertain the VO2 max scores of 30 sedentary male university students from West Bengal, India. The two tests exhibited significant statistical correlation between them. This suggests that the Queen's College step-up test is a more accurate test for working out VO2 max than the multi-stage fitness test, as there is a direct and obvious relationship between the two tests. Using this study and the other information that I've gathered suggests that the more accurate and reliable test for measuring VO2 max is the Queen's College step-up test. The accuracy of this test in comparison to the multi-stage fitness test is closer to that of the gold standard test. The gas analysis test. The Queen's College step-up test is a sub-maximal test, meaning that maximum effort from the participant is not required and therefore is easy to carry out for people who may struggle to give maximum effort because of their age, physical ability, injury, etc. The multi-stage fitness test is a maximal test and so requires participants to give their maximum energy. This can be difficult for those who are not able to do it, making the Queen's College step-up test more accessible to people. The Queen's College step-up test requires the testers to have a speaker or metronome of some kind, as well as a step, and so can be very cheap to access and carry out. And finally, the Queen's College step-up test requires a very small amount of room, enough to fit a participant and a step. It is similar to the multi-stage fitness test, which requires 10 to 20 metres of room, making it a more attractive option to those who have smaller accessible space.